All right, in this example, we're given the function f of x equals x cubed. And we want to sketch the graph of f of x and a new function g of x, which is a transformation of f of x. All right, so let's see if we can think about what this means. Let's focus in first on this f of minus x. What does f of minus x do? It reflects it across the y-axis. So this is reflected, reflected across, oh my gosh, across the y-axis, right? Y-axis. Okay. All right. So negative x's become positive, and so it reflects it across the y-axis. And then we've got this multiplier of a half, right? So this is a vertical compression. Actually, just let me make a list of here. The next one is a vertical compression. Vertical compression by a factor of 2, or sorry, by a factor of 1/2, right? So we're compressing it, right, by a factor of a half. And then we've got this -3 at the end. Now that's a vertical shift down by 3. All right, so a reflection and a compression, and then we have a shift down by 3. Okay, it's a vertical compression. All right, so that's what's going on here. But now we need to graph it. So, all right, it's always a little challenging because let me see if I can do it like this. Let me just draw an axis like this. And I'll draw another one. This would be the easy way to draw an axis, maybe. Draw another axis like that. Now I could make a table of values, but I am going to, I can easily cube numbers, right? So 0 cubed would be 0, so 0, 0 is going to be on the graph. Now I better put some numbers on here. It's going to be kind of a rough sketch, so I'm just going to put some tick marks on here. Try to get them evenly spaced as much as I can. 1, 2, and then put a scale on it. This is going to be x, this is going to be y, which is f of x. -1, -2, and of course this would be -1 and -2 in the y direction. All right, so when I cube 1, I get 1, right? If I cube 2, I get 8. So it's going to be way up here. So I'm just going to kind of connect these up like that. If I cube -1, I get -1. So this point's going to be on there. And if I cube 2, I get 8. So it's way down there. So I can kind of sketch what this function looks like. Something like that. This is f of x. All right, let me switch colors. And let's now take a look at the graph of what we're trying to do here. All right, so now I could again make a table of values because all g of x is, like, it's just, it's going to be, I can write it out, g of x is equal to 1/2 of negative x cubed, right? Because f of x is negative x, and sorry, f of x is x cubed, and where'd my green pen go? Is that green? Okay. And then I'm going to subtract 3 from it. So I could, whoops, I meant to put red there. So -3. All right, so oops, and there's a big cube there. I could just put values in, but let's try and use the transformations here. We're going to reflect it across the x-axis. We're going to compress it by 1/2 and then down by 3. So, well, I don't know. Maybe a table of values would be good, but let's look at it this way. There's a number of different ways you could approach this. A table of values would be great, but we know what f of x does, right? So let's just draw it this way. Here's f of x, or the f function. Oops, Okay, this is the f function. All right, and we know it has some input and some output. In this case, it's negative x that goes into it. Let's see, negative of whatever, right? Negative x goes into it, so we put x in. And then on the other side, when we get the output, we're going to take half of it. So we're going to half of it, right? And then we're going to subtract 3. Oops. We're going to take the output of it and subtract 3. Okay. All right. So that's one way we can represent this function. And so we know how f operates, right? If we put in 0, we get 0. If we put in 1, we get 1. If we put in 2, we get 8. All right. So those are our outputs and inputs, right? Now, in order to get 0, here at this stage, negative, it's still 0. Negative of 0 is 0. So here we would need negative 1 in order to get 1, and then here we would need negative 2 in order to get 2, right? Because we're taking the opposite sign of the input before it goes into the function. All right, so now we got to run the outputs through the half function, right? So we're going to get 0, we're going to get 1/2, and then we're going to get 4. And then we're going to subtract 3 from it. So, and then we get the final output. So subtract 3, we're going to get -3. Subtract 3 from 2.5, we get a negative 2.5. And subtract 3 from 4, we get 1. So these, this transform function, these are the inputs and these are the outputs. So these are the coordinate pairs that we can graph. All right, so 0, -3. We got to add a little bit to this graph. So let me put a -3 here, and then we're going to have a point there. Actually, I think it probably has to go even farther down. So let's put a -4. All right, so we know that when we put in 0 and it goes through all these, this whole process, we get a -3 out. All right, if we put in -1, we get a -2.5, which is about here. Actually, I should be drawing this in red so that you can see it. So it looks different than the other one. And when we put in 2, whoops. Yeah, we put in -2, right? And we're going to get 1, a positive 1. So it's going to be here, right? So I've got half of it drawn. Kind of looks like that. I don't know if I like that. Let me draw it. All right, so it's going to look a little more like that. Now, we could put in positive 1 too, right? And if we put in positive 1, we would end up with 3.5. So it's symmetric. It's the cubic function. It's just shifted down, and then it's going to look something like that. It's reflected and then compressed and then shifted down. So you can see that in this portion of the curve, it's a little less steep because it's been compressed. It's less steep than in the corresponding portion on the other curve. All right, so I guess that's all we have to do is sketch the graph. So I guess that's good enough. This is our sketch of g of x. All right. All right. Well, I'll meet you in the next video for the next example.